You're still talking about beaming aboard the Enterprise while she's travelling faster than light without a proper receiving pad. Get off there!
I think Scott is concerned about the wrong thing here. Is that really possible? Can a giant spaceship go faster than the speed of light? Hello everyone, my name is Sundquist, and today I will help you all to answer this question. To do so, we will be using the concept of relativistic momentum. To first understand this concept, we have to review normal or linear momentum. The equation is as follows, where p is momentum, m is the mass of the object, and v is the velocity of the object. For example, let's say this car is about 1,000 kilograms, going about 27 meters per second. That comes out to 27,000 kilogram meters per second. Fairly simple. Let's continue with the car example. Imagine its head beams are on and light is flowing out as the car is speeding along, and we wanted to figure out the momentum of the light. With linear momentum, we should add the velocities of the car, which is still 27 meters per second, and of the light, which is about 3 times 10 to the 8th meters per second. But according to Einstein, who came up with relativistic momentum, we can't do this. He says nothing can go faster than the speed of light. This is where things start to get a little complex, but I assure you it will be fine, and really straightforward once you figure out how to do it. We can no longer calculate momentum from the perspective of the car. We will need to do so now from the perspective of an observer. This will change the equation just a little bit. Obviously, P will still stand for momentum, M will be the mass of the object we are observing, and U is now standing in for V. They are the exact same thing, you don't have to worry about that. U just tells us that we are now observing the velocity rather than experiencing it. Gamma, the little y there, is the only thing we are truly changing about this equation. It lets us have more accurate numbers when nearing the speed of light. We can break gamma down into this equation. 1 divided by the square root of 1 minus u squared divided by c squared, where c stands in for the speed of light. This only helps us to compare things barely under the speed of light. For example, if we had a very small u, say 100 meters per second, a very small number divided by a huge number squared is essentially 0. And 1 minus 0 is 1, and the square root of 1 is 1. So that makes gamma equal to 1 divided by 1, or just 1, making it not affect momentum at all. Only when u nears the speed of light will we see some changes. So let's change our example of a car to an electron. Electrons can go at 98.5% the speed of light, or 0.985 c. This is an example taken from the textbook, so don't worry, I'm not making up any numbers. We don't know the momentum, but we do know the mass of an electron to be 9.11 times 10 to the negative 31st kilogram. That is very small. We also know the velocity is 0.985 c. So when we plug all the numbers in, we get a momentum of 1.56 times 10 to the negative 21st kilograms meters per second. Not bad. But now, let's use our newfound knowledge to see if Scotty was right. Let's say the velocity of the ship is 1.01 c, faster than light as Scott told us. We don't want to get too crazy here though. The Enterprise weighs 4.5 metric tons, or 4.08 times 10 to the 9th kilograms. That's pretty big. That puts its momentum at... Let's start with the gamma part of the equation. Once you put in all the numbers and plug and chug, turns out this doesn't work. Since the numerator is larger than the denominator, we get a number larger than 1. 1 minus a number larger than 1 is negative, and you can't have a square root of a negative number. Turns out that Einstein was right. Nothing can go faster than the speed of light.
You're still talking about beaming aboard the Enterprise while she's travelling faster than light without a proper receiving pad. Get off there! It's not a climbing frame. The notion of transwarp beaming is like trying to hit a bullet with a smaller bullet whilst wearing a blindfold, riding a horse.
And that is after you did something to move faster than light, Scotty. Which you can't.